afternoon, everyone. Can everybody hear me now? Okay, nice. So let us start. My name is Dinesh, and I will be your CS111 e-mentor for this semester. Right. So I see quite a number of students in this session. I hope that you will enjoy what I have to share with you people. Right. So so everybody can hear me, right? Okay, so I will be turning off my webcam for now, and then we'll discuss with the presentation, right, that I have prepared for you, right? Okay. So how many of you have had a look at the presentation for now? Okay. So what we are going to discuss first is going to be increment and decrement. So can anyone tell me what increment and decrement actually would mean? Yes, anyone? I hope I am loud and clear to you guys. Okay. Ratu, Tevita, are you able to hear me? Okay. Okay. So, anyone, what do you think is increment and decrement?
Changing variable.
Changing variable? Is it? Okay. Let me see. If I have to say increment, that would be, I could say is another way of saying you are increasing something, right? And decrement, on the other hand, would mean that you are decreasing something, right? So that particular concept, I want you to actually picture it using variables, right? Now, if I have to say, so I would say increment would mean increase and decrement would mean decrease, right? So now, if I have to say, when you apply that to the let's say variables, right? You are trying to actually increase and decrease whatever is stored in a variable, right? Now, anybody could tell me what is a variable?
What programmist store?
Exactly. Thank you. A variable is actually used to store something, right? Store, let's say, a value, right? Just an example, right? Like, if you want to, if you're going to work and you want to take your lunch in a lunch box, right? So, what would represent your variable there? The value, let's say, is food, right? What would be your variable there? Yes? Anyone?
Pardon?
Can you come again, please?
Can you repeat the question, please?
So I was saying that if you're, let's say you are going to your work, right? You're going to your workplace, and then let's say you are taking your lunch, right? In a lunch box, right? Everybody could hear me, right? You are taking your lunch in a lunch box, right? Let's say the value there is lunch, right? What would be your variable? Lunch box. Thank you, Walter. Exactly. The lunch box is going to be a variable. The reason being, it is containing the food. It is storing the food there, right? So that is how variables in this CS111 actually work, right? Now, so let's say if you take into account this counter, right? So what does counter plus plus mean?
Add 1 to the counter?
Can you come again, please?
Add 1 to the counter?
Exactly. And this would actually represent what? As counter plus plus would be equals to what? Sorry, not equals to. I would say this would mean what? Counter is equals to counter okay. Okay, can you wait? So we have a question. So what's the difference between okay, so everybody could hear me now, right? So I was saying that counter there would actually mean counter plus plus, is it? Right. So counter there would mean counter plus plus and what would actually counter minus minus mean? Anyone? Yes, Ratu? Decrease by 1, exactly. So counter plus plus and counter minus minus would mean, like counter plus plus would mean counter is equals to counter plus 1. You increment what is in counter and then you store or you override that counter value, right? And just like that, counter minus minus would mean counter is equals to counter minus minus, right? Or counter minus 1, right? So so I was saying, so let us move to the next slide, right? That would be modulus. Now, who can tell me what modulus is? Or modulus or modulo? Anyone?
Remainder of an integer division.
Can you come again?
It computes the remainder of an integer division.
Exactly. So modulo actually means that you divide two numbers, right? And whatever the remainder that you get, that would be your output, right? So that is what actually it means, right? Just like let's say 5 divided by 2, right, is 5 divided by 2, right? That should be right. So how many times 2 can actually go into 5? I would say 2 times. So I would say 2 times 2 is equals to 4, right? And then you'll get a remainder of 1, right? Then, right, 4 times 2 times 2 is equals to 4, and then you will get a remainder of 1, right? Now, let me see. So, what would be the modulo of that? Yes, modulo of that would be 1, exactly. So, your answer would be 1 there. So, that is exactly how the examples that you can see in this slide, that is actually how it works, right? Now, if you divide 9 from 3, and what is the symbol for a modulo that is shown in the slide? The modulo sign is actually the percent sign, right? So if you can see, let me show you this. This is your modulo sign, right? So likewise here, the modulo sign here is this one. Percent there, percent here, and percent here, right? So far so good, and everybody can hear me, right? Very good. Now, so if you divide 9 by 3, right? What should 9 divided by 3 is actually what? 3. So 9 divided by 3 is actually 3, right? So why do you think the modulo that we are, or the value of the modulo that we are putting there is 0? Why do you think so? No remain. So I would say 9 divided by 3 is equals to 3, and the remainder would be what? 0? Right. So that is why we are taking this, right? Let's say this 0, right? We are taking this and then we are giving it as an answer, yeah, right? So that is how modulos work. So far anyone has any question on increment and decrement and modulo? Anyone? Everybody is fine with that? Okay. So now, so let us move on to the next slide. So the next slide is some of the formulas, right? How you're going to write some of the mathematical formulas in while you are actually writing a program, right? So for mathematical expressions, there are some inbuilt functions as well, right? In C++, we have some inbuilt functions that you should be aware about, right? So I will go, I will explain to you a few of those, a few of those functions, right? Now, what about C? If you can see the first mathematical expression, this one I would say, this one, x plus y is divided by 2, right? So first, so with that, you're going to use brackets, right, for x and y to explain or show that first you are going to add x and y, right? Right? So what about this one? Right? What about this one? If you see x times y divided by 2 mathematical expression, right? And what is the mathematical expression or mathematical sign that we are going to use in C++? Exactly. An asterisk is going to represent your x plus y, or sorry, x multiplied by y. Right? So if you can see, and why do you think that when we are multiplying x times y and then dividing by 2, why aren't we using a bracket there? According to the slide, why aren't we using the bracket there? Because mathematically, in multiplication, right? In multiplication, right? You can multiply anyhow, right? You are going to still get the same answer, right? When you are multiplying, right? Let's say, if I to say, let's see, right? So I'll say, right? So let's say I have to write 2 plus 4, right? And then slash 2, right? So I'd say 2 plus 4 equals 2, 2 plus 4 divided by 2, right? It should equals to what? Should equals to 3, right? But if I am saying, if I'm using without brackets, let's say 2 plus 4 divided by 2, right? Then what would be your answer? Exactly. The answer is going to be 4. The reason being that 4 divided by 2 is actually done first, right? And then followed by that it is added to 2. So that in that case we are going to get an answer of 4, right? So it is very important that we place the brackets at the right place, right? To know where, right? To know which operation should be done first. Right? If you see in the second line that I have typed, the first operation that is done first there is divided. 4d is divided by 2, the value you get is 2. Then that 2 is added to the first value. Right? That is how you are getting 4 there. Right? But let's say, if I have to say 2 multiplied by 4, right? And then I am dividing by 2. Then what is your answer? Your answer is, the answer you're going to get is 4. Exactly. Thank you, Tevita, for bringing to our attention that we are going to use BADMAS, right? So BADMAS rule is also used in C++ as well, right? But when it comes to, so let's move on to this multiplication part, right? So in multiplication we are getting is like 2 multiplied by 4 divided by 2 is equals to 4. Right. So if I have to use a bracket instead of 2 like this and then divide by 2, what would be your answer there? Will that still be 8 or will that be 4? That is going to still give you the value 4, right? So if you see, right, why we are using the brackets in addition and not multiplication, because in multiplication if you put brackets or you don't put brackets, it is going to give the same value at the end, right? So let us move on to the next function there. So if you see, this is a compound function or power function, right? We have a mathematical function, right? And that power function is actually represented by this power function, right? Power function there. Right? So this is O. This is to represent function, right? So whatever is the power, right? So, and that inside that power function you have this one value and then comma and then another value, right? The first value is same as whatever you're getting in the bracket, right? And the following value after the comma is going to be your power, right? Right. Now, this function, the square root function, right? So in C++, we have the square root function is actually represented by sqrt, right? And then inside the bracket you have all the values there. A multiplied by A, and b plus b multiplied by b. So in C++ we do not have the square function, right? We do not have the square function. That is why it is multiplying a by a and then b by b, right? And then likewise, in the last one, right? Again, it's all about mathematical. So it's an addition expression there, right? So you have to use the brackets first, and then you everything, then you divide by 3, right? So let us move on to the next slide, right? The if statement, right? So how do you think the if statement is going to look like if you are actually typing in the code? We'll have something like this: if, let's say, and then some condition, right? And then following that, you will have your brackets, right? And then once that done, right, if, and then you'll have an else, or else. Right. So that is actually how you're going to have your if and else condition there. Right? If you're going to have your if and else. So anybody has any question about the structure of an if and else? Okay. Okay. So if and else. Right. So let's give let's say a real life scenario, right? So let's say a person is let's see, right? I would say Johnny is Johnny is going to school, right? So let's say if he goes by bus, then he will pay the fare, right? Otherwise, he will save money, right? Right. So that is how the if and else statement is going, structure is going to be depicted, right? Let's say Tony is going to school, right? So if he goes to school or goes by bus, right? So, right? If he goes by bus, right? So here this is let's say, right? That would be your what would actually that be? That would be your condition for your if, right? If he goes by bus, right? And then if he goes by bus, then he is going to, or he will pay the fare, right? So if he is going by bus, right? If he is going by bus, so goes by bus is your condition there, right? Right? Then he will pay the fare is whatever that is going to be inside the if statement, right? It's going to be like this. So yeah, I would say if Right, exactly, Jimson. If going by bus, right? So what is going to be in the if statement there? Inside the if statement, it's going to be it's going to be by the fare, right? And then you close that if statement, right? So if he goes by bus, then he is going to pay the fare, right? So that is how you're going to depict your if statement, right? So if he doesn't go by bus, then what will happen? So he will say else, right? Otherwise, this is the denoting else, right? So else, I would say, right? I would say else save money, right? And then you close the statement there. Right? So that is actually how you're going to have your if and else statement for this scenario here, right? So if you look at the question, the slide, it says the if statement allows a program to carry out different actions, right? Depending on the nature of the data being processed, right? So if you look at the scenario that I actually created just now, then you would have been able to see how I actually extracted the condition and whatever goes in the if statement and what goes in the else statement, right? So that's what I've actually extracted. So depending on that, the scenarios will change. It's all about how you're going to place your conditions and your executions, right? The if statement is used to implement a decision, right? Implement a decision, right? So exactly what we did there. So the decision that Chone was supposed to make is to go by bus or not to go by bus, right? So when a condition is fulfilled, right? So if Chone goes by bus, so the condition goes by bus is fulfilled there, right? Then he will pay the fare, right? The money, he will pay the fare, right? So that is the statement that is executed, right? Right? Executed. So otherwise, right? So otherwise is represented by an else, right? Another set of statements is executed, and another set of statements that is executed would be Chone saves money. If you look at the scenario there, right? Chone is going to save money, right? So that is how if and else structure actually works, right? So let us move on to the next slide. Right. So yeah, this is a very good example here of how if and else structure is actually going to work, right? Yeah. See this line, your condition is here, right? And then this is your statement for the if condition, right? And this is going to be your condition for your else, right? So if this decision, if the flow is greater than 13, there you should see the condition there. If the flow is greater than 13, then you execute the statement, right? You will only enter the statement. Let's say, right? So you will only enter this statement if this if condition is met, right? And then if you will only enter this condition or this statement if this condition is not met. Let's say if the flow is less than 13, then it's going to discard this, right? It's going to discard this and then move on to this condition. Then your actual flow will be equal to flow, right? So that is how it's going to be your if and else structure, right? If the first condition is not, if the if condition is not met, then you move on to the else, right? That's how it works, right? So now, what is going to So what we are going to do now is move on to the next slide, right? Slide 7, right? So this is what we call this right? So this is your so that is how we are going to have your if and else structure there. So flow is greater than 30, right? So comparisons, right? These quantities are compared, flow and then 30. If flow is greater than 13, if that condition is met, right, then, right, so if you see in the balloon that is shown there, check that you have the right direction, right, greater than or less than, right. So that is something that you have to think about while you are setting the conditions, right. So let's say instead of you wanted to actually check if the flow is greater than 13 and then you actually ended up writing the flow is less than 13, then there won't be a syntax error, but your execution of your program is going to be very different then, right. And then check the boundary of the condition, right. Do you want to include greater than or equal to? Not exactly, Tevita. It's like it's an option that you have. If you have option that you have, whether you want to have an else statement or not, right? Let's say if you have a, let's say, example, if let's go back to the previous example that we did about Chone and the bus, right? So if Chone, let's say, goes by bus and then he pays the fare, right? Otherwise, let's say he does nothing, right? So in that case, if Chone pays the fare, right? That is the condition there, and then if that condition is met, then he is going to pay the fare, right? Else, right? Else is going to do nothing, right? So in that case, that is no use having an else statement because you don't have anything to execute in the else statement, right? So if you don't have anything to execute in the else statement, then I would suggest you don't have the else statement, right? To save some lines, right? So far so good, everyone. Everybody can hear me clearly. Anybody else have any questions so far? Right. So shall we move on to the next slide? So right. So here we go. You have multiple if and else statements, right? If you, let's say, for example, right, so let me write something here. So I've created a scenario here. So if Tony goes by bus, then let's say he will pay the bus fare, right? Bus fare there. And then if he goes by a car, right? If he goes by a car, then let's say he will get a free ice cream, right? And then if he walks down, then he will get, or he will save money, right? So if you can see this, if you have a look at this scenario, we have about three different conditions or three conditions that need to be met, right? So in such scenarios, right? So I would actually say, so let's create an if and else structure for that one, right? So I would say if goes by bus, right? Then yeah, right? And then I'm going to close that. So I've closed it there, right? So else if, so when you are dealing with two or more if and else, let's say two or more conditions that need to be met, then we'll use if and then followed by else if and then else if and else if. Depends on the number of conditions that we have, right? So in this case, if you'll see, we have three conditions that need to be met, right? So I would say if he goes by bus. So one condition there is if he goes by bus, right? Right, if he goes by bus. Right, so I was saying, let's say, let's replace this situation there. So if Tony goes by bus, right, then he will have to pay, right? Else if Tony goes by car, then he will get a free ice cream, right? Else if, no, not else if. And if he walks down, he will get, he will actually save money, right? So what we are going to do here, right? So what we are going to actually do here, let's write the if and else statement again, right? Sorry about this, right? So if bus, right, then fare, right? Then like I said, if you have more than two conditions that need to be met, you will say else if, let's say goes by car, then what is going to be the execution there? Execution is going to be gets free ice cream, right? And then else. The final condition you can place else there and then the braces and then say saves money there. Right? So that is this is the what do you call this example for the scenario that we created, right? The if and else structure, right? So this is the first condition that is met, needs to be met, right? And then followed by the second condition, if it goes by car, then The third condition we do not actually say. So if if the first two conditions are not met, then obviously we'll go on to the third condition. So the compiler will actually know that in the third condition, what the third condition would be. So that is why we're not specifying what the third condition is there. Right? So that is the reason there. And that is what is very much explained somewhere here, right? If Richter scale is greater than equals to 8.0, then execute this statement. Else if so, if you see there, they are about what? 1, 2, 3, 4, 5. 5 conditions that need to be met there, right? So obviously, if the first 4 conditions are not met, then obviously the last condition will be met. So for that one, we are not specifying the condition, right? So let's move on to the next slide. Right, in the next slide. In the next slide. Right, so in the next slide, we have what? Right, normally at USP. So okay, so let me see. Right, so this is the conditions that is given there, right? So if you look at the grading system at USP, right? So if we are going to implement that using if and else structure, right, it's going to be something like this. The first condition is going to be a what? What is your first condition going to be? Anyone? The first condition is going to be if your grade or if your value is between 85 and 100, then inside that condition you will have an A plus, right? Then else if your condition should be 78 to 84, then within the braces you will have an A there, right? And like if you follow on, the conditions will be 71 to 77, then you will get a B plus, 64 to 70, then you will get a B, 57 to 63, then you will get a C. So this is very much like what you are going to get here, right? What you are going to get here. If, let's see, if your mark is between 85 and 100, then instead of short maximum you will get an A plus, right? And then if else if your value is between 78 and 84, I think, yeah, 78 and 84, then you will have an A there, and then it will follow on, right? Now, our final condition, right? So this is actually how you're going to write a pseudocode, right? Can anybody tell me what a pseudocode is? Okay. So, okay, let me explain on pseudocode, right? So, if you see, this is very much similar to how you are going to write your code, right? But the only difference is that this is not in C++ mode, right? You are actually writing it. Remember that scenario that I have actually created, and for that I created an if and else structure there, right? Within that I was writing words and not syntax, right? C++ syntax. That is actually what we call a pseudocode, right? If Sone goes by bus, right? Goes by bus. In the bracket I written goes by bus. Then exactly, Devika, it's a notation that is actually resembling a code, but it's not actually a code, right? It's written now in words maybe, right? Just to give a brief idea of what we are going to. what we are going to get in the, or what we have to write in the actual code, right? So with this, do you have any questions so far? We'll end the session here. Before that, do you have any questions? Anyone? You are most welcome to type in the questions if you have so. And before everyone finishes the session, can you please all give me your student IDs, ID numbers, so that I can provide you with the attendance for this week? Maybe in the chat box. It would be much appreciated. Okay.